What is the integral of a to the x dx between 1 and infinity, in which a represents any constant, such as 2 or 3? Well, to evaluate such an integral, we're going to have to use a few properties of logarithms, in which a to the x equals e to the power of ln a to the x, in which e to the ln would cancel out, so a to the x would equal a to the x. We can apply one more property in which we're taking the power of whatever was inside the logarithm, which so happens in this case to be x, and putting that as a constant to the overall exponent of e. By that I mean e to the power of x times ln of a. Knowing that, we can apply this to the integral, in which it's between 1 and infinity of now e to the x ln a dx. Fortunately, we can evaluate this using u substitution, in which u equals x ln a, whatever was in the exponent for e, and taking the derivative of that, du equals just the constant in front of x, or in this case behind x. Du equals now only ln a dx. Rearranging, we get dx equals du over ln a. And now we can put this back into the integral, and I'm not going to worry about changing any boundaries. I'll apply that later. So I'll just make it an indefinite integral of e to the u, where u is x ln a, du over ln a. Rearranging, we get 1 over ln a times the integral of e to the u du. And as you know, the integral of e to the u with respect to u is again just e to the u. So that's 1 over ln a times e to the u. Don't worry about the plus c, because we are going to apply the boundaries right after this. And back subbing so that we have consistent boundaries, we have 1 over ln a times e to the x ln a, which we said was u up here. Now we can finally apply the boundaries of 1 and infinity, and since 1 over ln a is the same as 1 over ln 2, we can keep that outside, so it would be 1 over ln a times the boundary of e to the, I'll bring ln a in front since it's also just a constant, times x, between 1 and infinity. Once we evaluate this, we get our answer. So this equals 1 over ln a. I'll put a parentheses, and since this is infinity, you're going to have to say formally the limit as n approaches infinity of e to the n, because it's going to be essentially e to the infinity times the constant, which remains to be e to the n. And this will be subtracted by the lower boundary of e to the ln a times 1, which is just e to the ln a. And evaluating this, we can easily see that e to the n will include infinity, so you could just say that's 1 over ln a times infinity minus e to the ln a. And since there's infinity in this expression being subtracted and multiplied, it will remain as some non-existent number. So we can say that this does not exist, or rather this is divergent. If this were to be infinity over infinity or 0 over infinity, that would be a different case, but we can just see it's being multiplied by given numbers. So, therefore, it is divergent. If you have any questions, please leave in the comments below, and good luck.